Hey everybody. So we're going to start with the next lesson of our scale factors and similarity unit. The only difference between this part of the second lesson, which is lesson 4.2, and the first lesson is that in the first lesson we discussed similar triangles. In this one we're going to discuss similar polygons. Now a polygon is defined as, and that's actually our first definition, a polygon right there. It's defined as a two-dimensional closed figure made of 3 or more line segments. And so in there you will actually see the word triangle being used as an example, and that is correct. A triangle is a polygon. However, the polygons that we're going to discuss today are actually going to be 4 lines or more, because triangles, the only difference between a similar polygon, which does not include triangles in this particular category, versus the similar triangles, is that the similar polygons, you have to make sure, in order for them to be similar, you have to make sure both criteria are satisfied. And so with similar triangles, we only had to prove one, that the corresponding angles were equal, or that the corresponding lengths of the sides are proportional. However, with a similar polygon of 4 lines or more, you have to prove both of them. That's the big difference between a similar triangle and the rest of the polygon, so anything of 4 sides or more. So that all being said, all we want to know is the following question. If you identify similar polygons, are these two triangles, they look similar, but are they actually, is this polygon actually a true enlargement of this polygon right there? And you have to explain. So if you look at the 4 corners here, this is M, A, T, H. And then what happens is we have this M apostrophe, A apostrophe, T apostrophe, H apostrophe. That apostrophe is actually called prime. Now, prime indicates automatically that this guy right here came after this guy right here. So I'm going to put a little note that this apostrophe equals prime, okay? And prime means it came after the original polygon. Okay, now if I was to put 2 apostrophes, it would be double prime. If I was to put 3 apostrophes, it would be triple prime. And long story short, the more apostrophes that I put, the more replications that we have of our original figure. Okay, so I want to prove that M prime, H prime, sorry, M prime, A prime, T prime, H prime, this guy right here, I want to prove that it's actually a true enlargement of this guy. So in order to do that, we have to prove 2 things. Number 1, we have to prove that the scale factors are, that the corresponding lengths of the sides are proportional. So we use the same number to multiply this, 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 and this to get all of these sides. And then we want to also prove that the corresponding angles are equal. So this all goes back to our first lesson. So the corresponding angles in this case is a little bit easier to work with, simply because if you have M, you're looking for M prime. That's your corresponding angle, because you use the same letter but with an apostrophe, which signifies prime. So angle M, and just a reminder that that L that's like slanted, that means angle. So angle M equals angle M prime, which equals, and because we have these boxes here, that means 90 degrees. So that right there. Now, the next thing we're going to prove is angle A equals angle A prime, which is they're both sitting at 100 degrees. So that's good. Angle T equals angle T prime, which equals, and they're both sitting at 80 degrees. Now, I know you guys can't see this last part that I've written down here, and you're not going to see the angle H. I'll move it down in just a second, okay? So angle H equals angle H prime, and because they are both boxes here, that represents 90 degrees. So both 90 degrees. So I'll show you guys what it looks like here. This is the work that you show to prove that the corresponding angles are in fact equal to each other. Okay. Now, going back to the sides now. Now we're going to discuss that. And I'll just move it up just a slight amount here so I can see all my work. So what we want to do is this time, instead of calling it a letter, like a lowercase letter like we would have done for the triangles, there aren't really any lowercase letters, right? Because this, the opposite side of it, is actually another angle, so it doesn't work that way. So what we do now is we call it a line segment. We start from one angle and we go all the way to the second angle. So for example, this line segment right here is called MA, or you can call it AM. It doesn't matter which angle you start with as long as you use the same letters. So this is line segment MA, and how we would write that out is the following. And I know you can't see these yet, but I'll show you in just a minute here. And actually, what we want to start with, and pardon me, to find the scale factor, we actually want to use the diagram divided by the original. So this guy, the second one, divided by the original. So we want to use M prime A prime. That's line segment M prime A prime. And I'll show you what that looks like. It's right here. So this right here just simply states that, it states that if I have M prime A prime, I put this big line above it, and that tells me it's a line segment. Now, it kind of looks like a division, so be very careful. And then you would simply divide. So you make a longer division. You divide it by MA, the line segment of that. Okay? Because it is always the diagram divided by the actual or divided by the original. So what I'm looking at here is this equals 4.2 divided by 3, which equals, I'll do my calculator very quickly here, 1.4. So that means that our scale factor was 1.4. So as of right now, what it's telling us is that this enlargement is 1.4 times bigger than my original. We need to prove that that is the case, in fact, for every single side. So the scale factor equals, now we're going to go to the next one, okay? So the next one we're going to do is AT and A prime T prime. Okay, so we do A prime T prime, that line segment, divided by AT line segment. And I'll show you guys what that looks like here. Tilt it. Okay, so we are looking at 4.9 divided by 3.5, and that gives me a total of 1.4 again, which is what we want to see, because we want to make sure that it gives me the same number as a scale factor in order for this to be a true enlargement. So moving along now, we're going to go back, some more scale factors. This time we're going to do T prime H prime, and then we divide that by TH, the line segment. Sorry, I'll just put this up here. Okay, and so then what we're looking at is, sorry, I can't see. Oops. 2.1 divided by 1.5, which equals 1.4, which is what we want to see. And then the final scale factor is going to be MAATTH. It's going to be M prime H prime, the line segment, divided by MH, the line segment. So this is going to give me, oh, and you know what I just noticed, guys? I just noticed that I actually did MH here. I used the wrong numbers here. Sorry about that. So what I'm actually going to do is I'm just going to fix this up super fast here. I'll leave all that work, but I'm just going to switch this up here, okay? This is actually going to be your MH prime and then your MH right here. And this guy is actually going to be your MA prime and MA. Sorry about that. I just noticed that now. So that being said, we're looking at 1.54 divided by 1.1. And that also gives me a scale factor of 1 decimal. So that's exactly what we were looking for, was a scale factor of all 4 of them being the exact same, okay? So now the question states for us to explain our answer. You guys know what that means? It means that you have to use your words kind of like as if you were a dictionary, okay? So why is this a true enlargement? Well, this is a true enlargement because corresponding angles are equal and corresponding sides are proportional. Now I'm going to be looking for these words specifically. Proportional. I'm going to be looking for those specific words, okay, guys? So you have to say it's a true enlargement because you have to use corresponding angles, equal, and corresponding sides, proportional, okay? So, and I think I added too many N's there for proportional. Yes, my apologies. That's the French side of me. It's double N in French, 1 N in English. Okay, so guys, you have to use the words proportional. You have to use the words equal. Don't get them mixed up. Angle is equal. Sides are proportional. Okay. All right. Now, if we just go very quickly off to this next guy right here. So example number 2 of our lesson. And this lesson will be over after this. Okay. So Jason wants to make an enlargement of the flag of Nunavut. So he knows that the 2 rectangles, JKLM and PQRS, are similar. So guys, you're not trying to determine if they're similar. The question actually states to you that they are similar. So what's the missing side length of rectangle JKLM? Now, here's the tricky part. In this question, it tells you he wants to make an enlargement. For it to be an enlargement, that would mean that he's making this after he makes this guy right here. So because he's making this second, this is considered to be our diagram, which means that these numbers and variables on this flag are going to be our numerator, not our denominator. Even though this is first, this is what we're being told he's making according to this flag right here. So be very careful on things like that, okay? Now, if you go and look at all this information here, okay, oops, sorry, apologies. If you go and look at all this information, he's trying to find the missing side of this right here. This is an X, okay, for those of you that can't really see, this is an X right here, okay? So what we do is we set up our proportion that we already know. So we don't know the horizontal side, but what we do know is the vertical side right there. So that's perfect. Because then we do our diagram divided by our original. And so it's 32 divided by 5. Now, why isn't this focusing as well? Let's see here. Let's see what that does for you. Much better. Okay, sorry about that. So you have your 32 divided by your 5, and this is going to equal. Now remember, the 32 is in accordance with 9 or the X. Nope, it's with the X. So this means that because they're on the same flag, they need to go on the same level. So it should be 32 equals X, and then 5 equals, and then the 9 will go on the denominator as well. So going off of, we've done this work before in the first lesson, but this is like that little trick that I showed you guys. So you look on the side with the variable, you use the number and you cross multiply it. Okay, so that's a multiplication right there. And then you're going to divide it by the number that follows. Let's divide by 5. So it becomes 9 times 32 divided by 5 equals X. And then you do that on your calculator. 9 times 32 divided by 5, and it gives you 57.6 centimeters equals X, because you are discussing a side length of something. And therefore you say the missing side length is 57.6 centimeters. And that, ladies and gentlemen, is how you do the entire lesson. So I'm hoping that this one will go well for you guys. It seems as though some of you happen to be doing really well in the first one. So I'm hoping the second one goes really well as the first one did. If you guys have any questions, you know how to get a hold of me. Good luck, everybody.